So a diffraction grating is a plate that contains many closely spaced slits. So all these slits are parallel. Often on the diffraction grating it will be quoted in slits per millimetre. When you're doing your calculations, first off you would convert it to N, which is slits per metre. So as we said, often you're quoted in slits per millimetre, and then in the calculations you need to convert that to D, which is our slit separation. And very simply, the slit separation is just 1 over your slits per metre. So it's a nice easy conversion, but it's something that's very easy to get wrong if you're not careful. So what we need to know is what happens when we have monochromatic light shone through a diffraction grating. So what happens when monochromatic light is shone through a diffraction grating? So have our diffraction grating there, monochromatic light is shone in, and we see on a screen some very clear dots occurring, like so. So on this screen here you would see 5 dots. 1, 2, 3, 4, 5. There is always one at 0 degrees from your diffraction grating. So perpendicular to your diffraction grating shone in, we call this our 0th order. You've then got a first order and a second order, and we repeat it in each direction. So each direction has a first order, each direction has a second order. And what you find, the angle to the first order are equal. And again, angle to the second order are equal. So we get a nice symmetrical pattern. The reason why we only get very specific points and we don't get any sort of continuous spectrum is because firstly we have diffraction through each slit. Often we're talking hundreds of slits per millimetre, so we've got lots of closely spaced slits. Each one has diffraction, and on top of that we get a lot of cancellation. We only have reinforcement in very specific directions. It is mostly cancellation. So each of these slits, pretty much all cancellation, only these, in this case, 5 very specific points do we get reinforcement, and we see the bright spots. Relationship for a diffraction grating, d sine theta will equal n lambda. So d is your slit to screen distance, sine theta, so theta is your angle from the central maxima, n is the order number, and lambda is your wavelength. So no matter the properties, you will always get the 0th order at an angle of 0 degrees along the normal, and then your angles are measured from that 0th maxima. One thing they quite like asking is what total maxima are you going to see. Key things to remember with this: sine theta has got a maximum value of 1. So if in this equation you put sine theta equals 1 in there, so you cancel it down to d equals n lambda, and then rearrange that to find out the number of maxima. And the key thing when you're doing this is you round down n to the nearest integer. So if you're given a question to find out how many maxima are present and you get an answer of 3.4, then you would only see 3 maxima. You're not going to see 3.4, you only see it at a whole